For thousands of years, we looked up at the night sky and got it completely wrong. We thought the sun orbited Earth. We believed the moon was a perfect sphere of divine crystal. We were certain that Mars had intelligent civilizations building vast canal networks. These weren't fringe theories. They were accepted facts, defended by the greatest minds of their time, written into textbooks and used to navigate the seas. Then telescopes came, then spacecraft, then data, and everything we knew was wrong. This is Myths of the Cosmos, and today we're counting down 10 space myths that humans once believed were absolute, undeniable facts. Myths that shaped civilizations, inspired wars, and delayed our understanding of the universe by centuries. Welcome to the history of being spectacularly, confidently wrong about space. Science isn't a collection of facts. It's a process of being wrong, slightly less wrong, and then finally, maybe, getting close to right. And nowhere is that journey more humbling than in astronomy. For most of human history, we didn't have telescopes, we didn't have spacecraft, we didn't have spectrometers or radio telescopes or gravitational wave detectors. We had our eyes, our imagination, and the overwhelming confidence that came from not knowing how much we didn't know. So we created myths, beautiful, intricate myths that explained the cosmos in ways that made sense with the tools we had. The sun was a chariot, the stars were holes in a celestial dome, the planets were gods wandering through heaven. But here's what makes this fascinating. Many of these myths weren't dismissed as mythology at the time. They were science. They were fact. They were taught in universities, defended by the church, and anyone who disagreed risked persecution or death. Today, we're exploring 10 of the most widely believed space myths in human history, ideas that millions of people across centuries accepted as truth, only to be proven spectacularly wrong. Let's begin with a myth so fundamental it literally put Earth at the center of everything. Myth number 10. The Geocentric Universe. For over 1,400 years, humanity knew that Earth sat motionless at the center of the universe while everything else revolved around us. This wasn't religious dogma masquerading as science. It was science, real, sophisticated, mathematical science. In the 2nd century, Claudius Ptolemy created a model so accurate it could predict planetary positions and eclipses. His Almagest became the astronomical textbook for over a millennium. It explained retrograde motion. It accounted for seasonal variations. It worked. The model required something called epicycles, smaller circles within larger orbits to make the math work. By the Middle Ages, astronomers were using dozens of these epicycles, creating increasingly complex geometric patterns to maintain the idea that Earth was stationary. Why? Because it felt true. Stand outside right now. Do you feel Earth spinning at 1,000 miles per hour? Do you sense it hurtling through space at 67,000 miles per hour around the sun? No, you feel still, solid, motionless. And if Earth were moving, wouldn't we feel constant wind? Wouldn't birds be left behind? Wouldn't dropped objects fly backward? The logic was sound. The observations supported it. The math worked. Then, in 1543, Nicholas Copernicus published De Revolutionibus Orbium Celestium on the revolutions of the heavenly spheres and suggested something radical. What if we've been wrong about which object is at the center? What if the sun doesn't orbit Earth, but Earth orbits the sun? The book was banned. Copernicus's ideas were declared heresy. Giordano Bruno was burned at the stake for supporting them. Galileo was placed under house arrest for the rest of his life. Because this wasn't just about astronomy, it was about humanity's place in the cosmos. If Earth wasn't the center of everything, then maybe we weren't either. Myth number 9. The crystalline spheres. Ancient and medieval astronomers didn't just think Earth was at the center. They thought the entire cosmos was a series of nested, transparent spheres, perfect crystalline shells, each carrying a celestial body. The moon sat on the first sphere, Mercury on the second, Venus, Sun, Mars, Jupiter, Saturn, each embedded in their own rotating crystal sphere. Beyond Saturn lay the sphere of fixed stars, and beyond that, the primum mobile, the first mover, the outermost sphere that rotated everything else. This wasn't poetry. This was the accepted scientific model of the universe for nearly 2,000 years. Aristotle proposed it. Ptolemy refined it. Medieval scholars calculated the thickness of each sphere, the speed of their rotations, and even the musical notes they supposedly produced as they turned, the music of the spheres. But there was a problem. In 1577, Danish astronomer Tycho Brahe observed a comet, not just any comet, a comet that crossed through the supposed paths of multiple planets. If the crystalline spheres were solid, the comet should have shattered them. It should have been impossible. Tycho did the math. The comet's parallax measurements proved it was moving through the space where crystal spheres were supposed to exist, and it passed through unobstructed. The spheres didn't exist. For the first time in human history, we realized that space wasn't a machine of nested shells. It was empty, vast, boundless. The cosmos wasn't a clockwork mechanism enclosed in crystal. It was an infinite void with objects floating freely through darkness. That realization was terrifying, because if there were no spheres, no structure, no cosmic scaffolding holding everything in place, what was preventing the heavens from collapsing into chaos? The answer would have to wait for Isaac Newton and a falling apple. Myth number 8. The moon is a perfect sphere. Ancient Greeks believed the celestial realm was perfect. Unlike Earth, messy, changing, imperfect, the heavens were eternal and flawless. The moon, they reasoned, must be a perfect sphere of polished crystal, reflecting the sun's light with geometric precision. Pythagoras declared it. Aristotle confirmed it. For 2,000 years, no one seriously questioned it. Then, in 1609, Galileo Galilei turned his telescope toward the moon. What he saw shattered the myth of celestial perfection. The moon had mountains, valleys, craters, shadows that stretched across uneven terrain. It wasn't smooth. It wasn't perfect. It was a world, a place, something almost Earth-like in its ruggedness. Galileo published his observations in Sidereus Nuncius, the Starry Messenger, in 1610. The book included detailed sketches of the moon's surface, showing features that shouldn't exist in a perfect celestial sphere. The response from the academic community was swift: denial. Critics claimed Galileo's telescope was faulty, creating optical illusions. Others suggested that while the moon appeared rough, it must be covered in an invisible layer of perfectly transparent crystal that smoothed out the imperfections. Yes, really, they proposed invisible crystal to preserve the myth. But Galileo had measurements. He calculated the heights of lunar mountains by measuring shadow lengths. He estimated some peaks at over 4 miles high, comparable to Earth's mountains. The moon wasn't perfect. It was geologically complex. It had a history written in stone across billions of years. And if the moon, the closest celestial object, wasn't perfect, then maybe nothing in the heavens was. Maybe the universe was as rough, scarred, and imperfect as we are. Maybe we weren't so different from the cosmos after all. Myth number 7. Mars has canals built by aliens. In 1877, Italian astronomer Giovanni Schiaparelli observed Mars during a particularly close opposition. Through his telescope, he saw what appeared to be long, straight lines crossing the Martian surface. He called them canali, Italian for channels, meaning natural grooves. But when translated to English, canali became canals, artificial, constructed, engineered. And suddenly, Mars had alien infrastructure. American astronomer Percival Lowell became obsessed. He built an entire observatory in Flagstaff, Arizona, dedicated to studying Mars. Between 1894 and 1908, he produced detailed maps showing hundreds of canals, straight lines crisscrossing the planet in geometric patterns. Lowell didn't just observe canals, he theorized their purpose. Mars, he argued, was a dying world. Its atmosphere was thinning, its water was evaporating. The canals were a desperate engineering project by an advanced Martian civilization, channeling water from polar ice caps to equatorial cities. This wasn't fringe pseudoscience. Lowell was a respected astronomer. His books became bestsellers. Universities debated Martian civilization as a serious possibility. H.G. Wells wrote The War of the Worlds, inspired by Lowell's dying Mars. The public was captivated. Mars wasn't just a planet, it was home to an ancient, technologically advanced species facing extinction. There was just one problem. The canals didn't exist. When more powerful telescopes were developed, the straight lines vanished. When spacecraft finally reached Mars in the 1960s and 70s, high-resolution images showed no canals, no geometric patterns, no alien infrastructure. What Schiaparelli and Lowell had seen was a combination of optical illusion and pareidolia, the human brain's tendency to see patterns where none exist. The canals were our imagination, projected onto Mars through the limitations of 19th century telescopes and the desperate human desire to not be alone in the universe. Mars was real, the canals were not. But the myth shaped science fiction, inspired space exploration, and reminded us that sometimes what we see in the cosmos is really just what we want to see. Myth number 6. The sun is made of burning coal. In the 19th century, scientists had a problem. The sun was clearly producing enormous amounts of energy, enough to warm Earth from 93 million miles away. But what was its power source? The leading theory? Coal. Not metaphorical coal. Actual, literal coal burning in space. British physicist Lord Kelvin calculated that if the sun were made of solid coal burning continuously, it could sustain its current energy output for about 5,000 years, maybe 10,000 if conditions were optimal. This created an immediate problem. Geological evidence suggested Earth was far older than 10,000 years. Charles Darwin's theory of evolution required millions of years. But if the sun couldn't burn longer than a few thousand years, then Earth couldn't be ancient. Kelvin's calculations were rigorous, his math was correct, and for decades, this paradox paralyzed science. Alternative theories emerged. Maybe the sun was powered by gravitational contraction, slowly collapsing under its own weight, converting gravitational potential energy into heat. Hermann von Helmholtz proposed this in 1854. Better, but still not enough. Gravitational contraction could only power the sun for about 20 million years. Better than coal, but still nowhere near the billions of years that geology suggested. The real answer wouldn't come until the 20th century. In 1920, Arthur Eddington proposed that the sun's energy came from nuclear fusion, hydrogen atoms fusing into helium, releasing tremendous energy according to Einstein's E equals mc squared. In 1938, Hans Bethe worked out the specific fusion reactions. The sun wasn't burning, it wasn't collapsing. It was converting mass directly into energy through quantum nuclear processes that no 19th century scientist could have imagined. The sun has been doing this for 4.6 billion years, and it will continue for another 5 billion. The coal theory wasn't stupid, it was the best explanation available with the physics of the time. Sometimes being wrong isn't about lack of intelligence, it's about lack of information. And the universe has more secrets than any generation is equipped to discover. Myth number 5. Space is full of luminiferous ether. For centuries, scientists understood that waves need a medium. Sound waves travel through air. Ocean waves travel through water. So light waves, which clearly travel through space, must also need a medium. They called it the luminiferous ether, an invisible, massless substance that filled all of space, allowing light to propagate across the cosmos. This wasn't mysticism, it was physics. Newton's optics discussed it. James Clerk Maxwell's equations of electromagnetism seemed to require it. Every major physicist in the 19th century accepted the ether as fundamental to understanding the universe. But there was a testable prediction. If Earth moves through stationary ether, we should detect an ether wind, a measurable difference in the speed of light depending on Earth's direction of motion through space. In 1887, Albert Michelson and Edward Morley conducted what's now considered one of the most important failed experiments in history. They built an incredibly precise interferometer designed to detect the ether wind. They detected nothing. No ether wind, no variation in light speed, no difference regardless of Earth's motion through space. The scientific community was baffled. Maybe the equipment was faulty. Maybe Earth was dragging ether along with it. Physicists proposed increasingly complex modifications to preserve ether theory. Then, in 1905, Albert Einstein published his special theory of relativity. He simply removed the ether, eliminated it completely. Light doesn't need a medium. It's not a wave in the classical sense. It's an electromagnetic oscillation that propagates through space-time itself. The speed of light is constant in all reference frames, not because it's moving through something, but because that's a fundamental property of space-time. The ether had never existed. For 2 centuries, we'd built our understanding of optics and electromagnetism on an invisible substance that wasn't there. Space isn't filled with ether. It's not filled with anything. That's what makes it space. And sometimes the most important discoveries come not from finding something new, but from realizing something we believed was never really there at all. Myth number 4. The Milky Way is the entire universe. Until the 1920s, astronomers believed the Milky Way galaxy was the universe, everything, the totality of cosmic existence. Yes, telescopes revealed fuzzy patches of light called spiral nebulae, but these were thought to be gas clouds within our galaxy, not separate galaxies themselves. In 1920, the Great Debate took place at the Smithsonian. Astronomers Harlow Shapley and Heber Curtis argued the question, are spiral nebulae inside or outside the Milky Way? Shapley argued they were internal gas clouds. Curtis suggested they might be island universes, separate galaxies far beyond our own. The evidence was inconclusive. The debate ended without resolution. Then, in 1923, Edwin Hubble made a measurement that changed everything. Using the 100-inch Hooker telescope at Mount Wilson Observatory, Hubble identified individual Cepheid variable stars in the Andromeda Nebula. Cepheids have a known relationship between their brightness and pulsation period, making them cosmic distance markers. Hubble's calculation was stunning. Andromeda was 900,000 light-years away. Modern measurements put it at 2.5 million light-years, but the conclusion remained the same. Andromeda wasn't inside the Milky Way. It was another galaxy, comparable in size to our own, floating in the darkness beyond. The universe wasn't just bigger than we thought. It was exponentially, incomprehensibly bigger. Hubble didn't stop there. In 1929, he made an even shocking discovery. Galaxies weren't just scattered through space, they were moving away from us. All of them. The farther away a galaxy was, the faster it was receding. The universe wasn't static, it was expanding. Suddenly, cosmic history existed. If galaxies were moving apart now, they must have been closer together in the past. Trace that backward far enough, and everything in the universe came from a single point. The Big Bang Theory emerged from this realization. For all of human history, we'd thought the cosmos was eternal and unchanging. Hubble proved it had a beginning, an origin, a moment when space-time itself came into existence. The Milky Way wasn't the universe. It was one galaxy among hundreds of billions, each containing hundreds of billions of stars in an expanding cosmos 93 billion light-years across. We weren't just small, we were a quantum fluctuation of insignificance in an incomprehensible vastness, and that realization changed everything. Myth number 3. Meteorites come from volcanoes. When rocks fall from the sky, where do they come from? For most of history, the answer was, they don't. Rocks don't fall from the sky. That's ridiculous. When people reported seeing stones falling during meteor showers, scientists dismissed them as superstitious nonsense. The sky doesn't contain rocks, therefore rocks can't fall from it. Logic. But the evidence kept accumulating. Witnesses described fireballs streaking across the sky, followed by impact craters and strange stones, often still hot with fusion crusts, showing signs of atmospheric entry. The scientific establishment needed an explanation that didn't involve space rocks. French Academy of Sciences member Antoine Lavoisier, the father of modern chemistry, examined reported meteorites and concluded they were either fraud, lightning-struck terrestrial rocks, or volcanic ejecta somehow thrown high into the atmosphere. In 1790, the Academy officially declared that stones could not fall from the sky because there were no stones in the sky. Case closed. Then, on April 26, 1803, something happened that couldn't be ignored. Near the town of L'Aigle in Normandy, France, thousands of witnesses watched a fireball explode in the sky. Over 3,000 stones rained down across the countryside, some weighing up to 20 pounds. The sheer number of witnesses and the massive quantity of stones made denial impossible. French physicist Jean-Baptiste Biot investigated. He collected samples, interviewed witnesses, and published a report confirming that the stones had indeed fallen from space. The French Academy reluctantly accepted the findings. Meteorites were real. Space wasn't empty, and Earth was constantly being bombarded by debris from the cosmos. This realization opened an entirely new field, meteoritics, the study of extraterrestrial material that falls to Earth. Scientists began analyzing meteorites' chemical composition and discovered they contained elements in ratios that didn't match any terrestrial rocks. These weren't volcanic stones. They were fragments from the formation of the solar system, 4.6 billion-year-old time capsules that predated Earth itself. Today, we know that 48.5 tons of meteoric material falls to Earth every day. Most burns up in the atmosphere, some becomes shooting stars, and occasionally a fragment survives to impact the surface. The sky isn't empty. It's full of ancient rocks, comet dust, and planetary debris, remnants of cosmic collisions billions of years old. And for decades, we insisted it was impossible. Myth number 2. Black holes don't exist. When Karl Schwarzschild first derived the mathematical solution to Einstein's field equations in 1916, while serving in World War I trenches, he discovered something strange. His equations predicted that if enough mass compressed into a small enough volume, space-time would curve so severely that nothing, not even light, could escape. Einstein himself rejected the idea. He published a paper in 1939 attempting to prove that such objects couldn't form in nature. The physics was clear. These frozen stars, or dark stars, were mathematical curiosities, solutions to equations that didn't correspond to physical reality. Most physicists agreed. The conditions required were too extreme. Nature wouldn't allow it. But in 1964, something changed. Astronomers detected intense X-ray emissions from a binary star system in the constellation Cygnus, Cygnus X1. The system contained a visible blue supergiant star orbiting something invisible. By measuring the orbital dynamics, scientists calculated the invisible companion's mass, at least 15 times the mass of the Sun. No known stellar remnant could be that massive without being visible. It was too heavy to be a white dwarf, too massive to be a neutron star. In 1971, astrophysicists concluded the only possibility was the object Einstein had insisted couldn't exist, a black hole. Still, many scientists resisted. Black holes were too weird, too extreme, too science fiction. Then, in the 1990s and 2000s, evidence became overwhelming. Astronomers detected supermassive black holes at the centers of galaxies, billions of times the mass of the Sun. They observed stars orbiting impossibly fast around invisible points in space. And in 2019, the Event Horizon Telescope collaboration released the first direct image of a black hole's event horizon, a glowing ring of superheated matter surrounding a dark void in the center of galaxy M87. The image matched general relativity's predictions with stunning precision. Black holes weren't just real, they were fundamental to cosmic structure, powering quasars, shaping galaxies, and possibly seeding the formation of cosmic large-scale structure itself. For over 50 years, we'd denied their existence because they seemed too strange to be true. But the universe doesn't care what we find believable. It contains black holes. It contains neutron stars where a teaspoon of matter weighs 1 billion tons. It contains dark energy that's accelerating cosmic expansion. Reality is stranger than we're comfortable with, and that's exactly what makes it worth exploring. Myth number 1. The universe is eternal and unchanging. For all of human history, across every culture, every civilization, every philosophy, one idea seemed self-evident. The universe has always existed and always will. Aristotle argued that the cosmos had no beginning. Medieval scholars debated theology but agreed on cosmic eternity. Even Einstein's first general relativity solutions assumed a static, eternal universe. When Einstein's equations predicted an expanding or contracting cosmos, he was so convinced the universe must be static that he added a cosmological constant, a fudge factor specifically designed to keep the universe from changing. He later called it "my biggest blunder." Because in 1929, Edwin Hubble proved the universe was expanding. And if it's expanding now, it must have been smaller in the past. Trace that backward far enough, and you reach a singularity, a point of infinite density and temperature where space-time itself began, the Big Bang. Not an explosion in space, but an expansion of space. The birth of time itself, approximately 13.8 billion years ago. The implications were staggering. The universe had a beginning, which meant it might have an end. Cosmic history existed. Time wasn't infinite. It was created along with space, matter, and energy in a singular event. Religious institutions claimed vindication. Science had discovered creation. Atheist scientists recoiled. A beginning implied a beginner. But the evidence kept mounting. Arno Penzias and Robert Wilson discovered the cosmic microwave background in 1964, the afterglow of the Big Bang, still detectable as faint microwave radiation permeating all of space. The CMB matched theoretical predictions perfectly. Its temperature, its uniformity, its tiny fluctuations that would eventually seed galaxy formation. Today, we have baby pictures of the universe, detailed maps of the CMB showing the cosmos just 380,000 years after the Big Bang, when it was hot, dense, and filled with plasma. We know the universe's age, 13.8 billion years. We know its composition, 68% dark energy, 27% dark matter, 5% ordinary matter. We know its fate. Expansion is accelerating. Galaxies beyond our local group will eventually recede faster than light, disappearing beyond a cosmic event horizon. Trillions of years from now, distant civilizations will look up and see only darkness. No other galaxies, no evidence of a larger universe. They might assume the cosmos is small, static, and eternal, just like we once did. The universe isn't eternal. It was born, it evolved, it will end. And for 99.9% of human history, we believed the opposite. 10 myths. 10 ideas that humanity believed were facts, defended by brilliant minds, written into textbooks and accepted as truth for centuries or millennia. Earth at the center of everything, crystal spheres, perfect moons, Martian canals, coal-powered suns, luminiferous ether, a single galaxy universe, impossible meteorites, non-existent black holes, an eternal cosmos. All wrong. But here's what makes this fascinating. Being wrong wasn't failure, it was progress. Every myth we've explored was the best explanation available with the tools and knowledge of its time. Each represented humanity's attempt to understand a cosmos far stranger than we could imagine. And here's the uncomfortable truth. We're still wrong about things right now. Dark matter? We don't know what it is. Dark energy? Same. The quantum measurement problem? Unsolved. The nature of time? Debated. Consciousness? Mystery. Future generations will look back at our current scientific understanding the same way we look at geocentrism and ether theory, with affectionate condescension and amazement that we believed such things. But that's not a failure. That's how knowledge works. We observe, we theorize, we test, we discover we were wrong, and we get slightly less wrong with each iteration. The cosmos is under no obligation to make sense to us, but slowly, stubbornly, one correction at a time, we're figuring it out. If you want to explore more cosmic mysteries, from ancient myths to cutting-edge physics, subscribe to Myths of the Cosmos, because the universe is full of secrets we haven't discovered yet, and some of the things we know today will be the myths of tomorrow. Until next time, keep questioning, keep exploring, and never stop being willing to be wrong.